All right. Welcome back for another episode of the Unplanned Show. With me today, esteemed guest Matt Stine, who you may recall from such hits as Migrating to Cloud Native Architectures, published by O'Reilly. Matt, go ahead and say hello, and then we'll cover some housekeeping, and then I'll come back for some questions on resiliency.
Is there anything else I don't know. It's unplanned, so I don't have any like scripted intro or anything. I'm here. I'm Matt, and I'm ready to talk about things with Domain, which is always a good time.
That's exactly how it should be. So thank you, Matt, for being on. Just to let people know, today we're talking to Matt on resiliency. Next week, we'll have Ashley Ward from Orca Security. And then after that, we'll have Charity Majors of Honeycomb and James Governor of Red Monk talking about LLM observability. So that was a fun pickup of a conversation the three of us started to have about a month ago. And then just before the Thanksgiving holiday in the US, we'll have Jamie Vernon on talking about building a culture of automation, topic he's spoken about before, but it's been probably about a year and a half, so good time to check in on his latest and greatest. I will also highlight, I am now one step closer to having the full-blown audio podcast version of the Unplanned Show available, so you can find it on Spotify now. Still working on setting up all the syndication to all your other favorite podcast players. But if you are a Spotify user, feel free to check us out there. All right. So Matt, resiliency is a topic I know that you know a lot about and have certainly written about in the past. But it's been a minute. And so some things have happened. We've all grown and learned. And so I thought I'd just take the opportunity to check in with you on what are you kind of thinking these days about resiliency, resilient architectures?
So I'm going to do what I've very often chosen to do in the past and answer the question that I choose to hear. Like my head's not directly on resiliency right now, but it is, which is because there's some aspect to it that's pertinent to almost anything that we do. And what I've been thinking about a lot more lately is how systems are not just technology. In fact, they're so not just technology that it doesn't really matter to me how much resiliency you say you've built into your system if you can't demonstrate the same rigor applied to how you think about humans and how they interact with the system and how they interact with each other when things, that are unplanned, right, will occur. There's a video that I only stumbled upon in the last few weeks. I can't remember how I stumbled upon it, but it's called the Bone Video. Have you heard of that one?
That sounds a little terrifying, and given the proximity to Halloween, that's just where
it's actually, yeah, it's a good tie into the season. Mm-hmm. So this was from DevOps Days Chicago, I think, in 2020. So it was like all the conferences were like you submitted videos and that was the conference, right?
Right.
So this was one, and I am absolutely failing to remember the person's name that was presenting, which I actually made a note to remember to write that down, but I never actually, wrote it down. But anyway, if you search YouTube for DevOps Bone Video, you'll find this, and it's about resiliency and how the bones are like not a model of resiliency so much as they're the archetype of resiliency. Like if you want to understand what resiliency is across like any place that you find it, there is no better place to look to understand and see what it actually means to be resilient than looking at bone.
Like human bones or like animal bones.
Yeah. Just like, so, look at how, bone, composed, from, calcium, and how, like, we actually don't have that, and I don't remember the number. Like, we don't actually have that much calcium in our body, and yet, like, that is what bone is. Right. So I mean, there's other things obviously, but so much of it is that, and we're constantly replacing that, and we have this whole complex, factory in our bodies that is constantly replacing and repairing itself, right? So, like, you get little fractures all the time that you never know you have because your body is repairing those. Like, much like, there's a chart out there somewhere that tells you, all the cells that you have and how often you replace all of them, right? Yeah. There are very few that, very little of you physically from when you were born still exists, even though you are still you. And that's a philosophical question for a different show. But it's that notion that, hey, there's this system that knows how to repair itself, and is also like, this is the thing that kind of keeps us, structurally, right, hanging out in the right places. Everything's protected, everything moves the way it needs to move. Right. If you don't have that system functioning well, then it's going to be very, very difficult for you to function well. And so you start to think about that as an analog into, how we build things. We still don't really, when we think about resiliency, we still don't really think of it that way. Of there is this, there are aspects of it. Like, we got really fancy with, what we can do with respect to, say, things like auto scaling systems, right? So it has a hard time responding to whatever is the bottleneck on that system's ability to perform, whether it's, the latency of systems behind it, whether it's the amount of traffic that's hitting it at one time versus what happens when you've got steady amounts of lots of traffic, all these different things that we look at, right? At the end of the day, we can measure those things and, to a certain extent, change the capacity of the system on the fly. Like, we have been really looking at multiple variations on how to solve that exact same pattern for at least the last several years that I've been paying attention to this space. Starting with how we did this in the Cloud Foundry world, and then how we do this with the the Kubernetes world, the Elastic, the EC2 instance world, all the different variations on functions, lambdas, that kind of thing. They're all effectively, how do you deploy some workload and then responsively adjust the capacity of that workload to handle what it's supposed to handle. And all these different solutions have a lot of trade-offs. And I'm taking a long way around to get back to where I started. But where I started was, it's not just the technology.
Right.
You can't take any of those things and apply it without thoughtfulness at bare minimum of, how am I going to use this solution to solve my problem, and how am I going to actually understand that I did it successfully, right? It's not enough just to go stand something up. It's like, did you build the right thing? And how do you know that? And how do you prove that without spending way too much money, right? There's all these things to consider. But then and we used to talk about, and we still do all the time in my current role, day 2 and day 3 and day 100 and day 1000. And when you come from the world that I'm sitting in right now, like, we're building systems that we know are going to be around minimum years. Sometimes we're thinking about things that, this thing is the predecessor was around for 20 years. So, and it took us this long to decide to replace it. So we're probably building something that's going to at least last some significant amount of time. And so the thoughtfulness that you put into something like, I'm going to be stuck with this thing for a long time, and I'm going to have to make it work, and I'm going to have to make it deal with all of the change that's going to come over that period of time, and not get to the point where I hate the thing that I made so bad that I want to get rid of it and replace it again.
Yeah. or kind of coming back to what you were talking about earlier with, the cells in your body that are constantly being replaced. So, the whole notion of, you look in the mirror now and like probably, I don't know, maybe none or very few of the cells the same that you had
Right.
as a child, right? And also the question of like, are you the same person? It's like, well, yes, but, you might make very different decisions. Hopefully you do. Make different decisions now than you did as a child or a teenager or young adult or whatever.
Right. Right.
You've learned. And so the idea of you're building a system that will be around for years, but will it be around looking the same? Or that's the, what is it? The ship of someone, I forget the Greek story reference, right? Where it's like, they changed the boat like plank by plank. And so at the end,
I know what you're talking about, but I don't know the name either.
I'm blanking on the name.
That's unlike me because I usually can pull that kind of thing out of nowhere, but oh well.
I know, here we are, how many cells have turned over, and the cells that used to know all of my classical Greek references may not still be with me. So just thinking about like, as you're looking ahead, building a system that you want to know that, hey, it's going to be around and I don't want to hate this thing. But also, how is it going to be something that can change plank by plank, cell by cell? Is that part of how you...
That's how I'm trying to think about things now.
Yeah. Right?
Because, and I feel like we started this conversation a few times in the kind of the first few years after cloud native became something that we started talking about, and we kind of stumbled on this notion that maybe we're about to do something that fundamentally looks a little bit different than what we have been doing. But then I think it kind of fizzled out a little bit, because we ultimately, I feel like we took a lot of these tools and techniques that were intended to allow us to do just that, to replace significant pieces of software while that software is also doing its job.
Mm-hmm.
And we've somehow managed to build a bunch of very ossified structure around it, to where we're using the technology, but we're still behaving as if we were using its predecessor in many ways, right? Like we have made it to where the way that we're allowing ourselves to consume these different technologies by how we decide to at scale, right? If you're talking about you're dealing with a huge organization, right? Something that operates in multiple countries, right? Something that has on the order of at least 10,000 technologists that you're trying to get somehow marching in at least somewhat the same direction. You have to standardize some things. So you can't just say, hey, everybody gets an account on the public cloud and can use whatever they have. That's not how it works. you put some structure around that. And that's the piece that I think that, we kind of stopped thinking differently, to borrow, the Apple tagline that we were talking about, that poster earlier. We started taking kind of the old mental models we had for how to do software at scale, and we kind of wrapped them around these new tools. And so the idea of me being able to say, hey, just this piece needs to change. Well, we can do that, but we've made it a lot harder than it ought to be. And in some cases, we actually we create constraints that will force us to create architectures that don't actually do what we want, which is, again, make it possible to when change occurs in either the business and what that software needs to be able to do, or all of the quality attributes that the software has in terms of performance and security and all these different things, those end up being moving targets as well. All of these things are moving targets. All of these things are change, but they're all changes that operate in different dimensions. And so, the way you structure software to optimize for change in the various business domains I operate in, and the way you structure for change in, the types of attacks that you want to be able to fend off from the outside of your organization, or the different ways that you want to be able to intelligently move traffic around the world based on where users are and keeping them close to their data. Like, there's all these different things that change over time. And then also, in the world that I come from, the legal frameworks that you have to operate within, because the electrons that are flowing through the circuit boards happen to reside inside these boundaries that somebody drew at some point in history, and then made laws that said, well, technology that lives here has to behave according to these rules. But as soon as you go across that imaginary boundary that somebody drew arbitrarily at one point in time, the rules completely change, even though it's the same technology. And if you want to operate in both of those jurisdictions, again, you have to be resilient to, well, what happens when there's a regime change and the laws all of a sudden change around technology very rapidly, or in the case of some of the startups that we're familiar with, like, the laws didn't change fast enough to keep up with what was happening, and you ran into all sorts of problems that theoretically, if you'd had reasonable guardrails in place, wouldn't have happened. But, well, before you knew you needed the guardrails, the problem had already happened. So, like, to me, all of these things are resiliency, which is why I kind of took the conversation maybe broader than you expected, because I think we need to learn to handle that kind of meta model well, because if we don't, and we end up just trying to handle each of these different silos of resiliency well as independent problems, I think we're going to miss something, because ultimately I think we're going to find out that all those little silos are a lot more tightly integrated than we choose to believe. Security is not entirely separate from performance, right? And in fact, they're actually quite related to one another. In some cases, in an adversarial relationship with one another. And so if I'm thinking about how to optimize for one to the exclusion of the other, I can end up backing myself into a corner architecturally or organizationally or both.
Yeah. It sounds, it makes sense, but it also sounds like something that would be a tremendous cognitive load.
Yeah.
on anyone who has to then think about, I mean, to your point, thoughtfulness, right? And that, like, I just am curious, like, what are your thoughts on, to your point, in very large enterprise, when you've got thousands, tens of thousands of engineers that you have to try to march in a direction, and also think about a meta model of factors to consider from a resiliency perspective. Is there some way to help?
Yeah, like it sounds like you're building the requirements list for the silver bullet right there a little bit. And gosh, I wish there was one, but there's not. There never will be one. I don't know that Fred Brooks meant to create the analogy to be as broadly applied as we've applied it, but I don't think it's gotten us into too much trouble saying, hey, there's no one solution to this. So, other than acknowledging, in my mind, that, hey, we live within a complex system. So how do we behave within how do we acknowledge that, first of all?
Mm-hmm.
And I was reading, I can't remember what it was I was reading the other day, but the statement was made that when you're in a situation where your kind of first level instincts about how to organize and do work kind of start to break down,
Mm-hmm.
and say, hey, we've gotten too big, it's too hard. We gotta loosen everything up, and give people the freedom to operate. And this other, voice kind of comes in and says, well, actually, yes, but not the way you think. You do need to learn to be able to move with kind of more decentralized thinking, but you actually need more rigor to do that, not less rigor.
Mm-hmm.
And again, one of the things that I think we missed, and we missed badly as an industry when we said, we're going to go all in on microservices, is we completely tossed rigor out the window. Mm-hmm. I mean, at least in so many of the places that I was able to observe, what does it look like 6 months, a year, 2 years after you've made the decision to do this? And invariably, everybody, including the people who were supposed to be good at this, made a big mess. And the people who are good at this have figured out how to back into rigor. Mm-hmm. And so a lot of the blog posts on the engineering blogs that I've seen over the last 2 or 3 years have kind of given you a snapshot of, well, here's how this organization kind of applied that rigor back to how we think about architecture at, big scale, right? Not how do we, not how do we stand up architectures at the level of a single team, but how do we think about having, an architecture that has some sort of conceptual integrity, but at the level of hundreds and thousands of individual systems that are interacting, and thousands and tens of thousands of humans who are turning dials and moving things around on that system every single day in the large, right? While one little piece of that might not change every day, that entire system that you can say is, this is my company system, right? Mm-hmm. Deployed the company today. That some part of that changes every day now.
Right. A cell is changing somewhere.
Yeah, right. We have, at least at this scale, managed to create something that does start to replace itself on some cadence, But when I look for, okay, what's the structure that makes this go? What is, and if you look at the human body, again, we'll go back to that example. Obviously, yes, this evolved. I'm not saying you can't evolve too, but it didn't evolve to, hey, so the people, you guys down there in the foot, you if you want to do agile, that's cool. Like, but if you want to do Kanban, that's fine. This arm over here, we're still on the mainframe, right? So that's not how it works.
Right.
There is structure there that is actually very highly organized. We're still trying to figure out how so much of it works, even though we figured out, the stuff that we have figured out, we've realized, it's some of it's like how we wouldn't have thought to design it this way, and yet it works so incredibly well. And here's all the resilience that's built into it.
Mm-hmm.
So clearly, and so this is where I start to get off into like meta philosophy and everything, and start to think about, well, is there actually conscious structure in the universe that we don't know about? Like is evolution a conscious process that we just can't understand because it's so big? I don't know. But all we know is that somehow we evolved to something. There's some mechanism that made us get to something that makes sense, and that you can actually see, here's how it works, and explain the structure. We haven't figured out how to reliably build a machine that does that with massive software systems that evolve over time, with massive, groups of people that, again, not just is the system changing out cells all the time, the teams are too.
Right.
The people come and go. But, I just rejoined for the second time the same part of my organization, and after going to work at another part for a while, and a lot of things, it's clearly still the same place, but so many of the faces have changed, and yet there's this cultural DNA that feels very familiar. Like, I know what it's like to work here. That's still kind of the same, right? So there's an identity there that's maintained, even though and so all I'm saying is, why don't we recognize and acknowledge that, hey, that's a thing, like there's structure here, and maybe apply the same mechanisms that we use to say, I'm going to go model a business and build software to run that business. Like, why don't we apply that same rigor to ourselves? Why don't we go introspective with software engineering and architecture and say, why don't we model the things that we're building? Why don't we model that explicitly? So this is a lot of the work that I'm, have been doing over the last year, is thinking about, hey, how do we stop thinking of architecture as, something that I draw with boxes and arrows and cylinders and circles and all these different, like, that is a view, that is a picture of the architecture, but it's just one picture. We know that if I look at it this way, there are other things that I'm going to be concerned about. I'm always choosing what detail am I going to include, what detail am I going to exclude? How many things, how few things, all these things are going into how I slice and dice that. But the slicing and dicing is always happening up here. Why don't we take that and put it out here and turn that into data? Yeah. So we start to think about, hey, the architecture is just data. We know how to manipulate data. We know how to analyze data. To a certain extent, like, if we could have like a data model that is, hey, this represents our software. Could I toss that to a large language model and start to say, hey, how does the FizzBuzz service work or whatever? And it could go out and like look at that model and say, oh, it works like this. Because we're doing that at small scale right now. Like, I even read an article 20 minutes before, I was killing a little time before we started this conversation. And I read an article where someone was using, I forget the Amazon service, but they were generating mermaid UML diagrams from. So, hey, take this code and give me a state chart for it. And it would spit out the mermaid code for that you could then run through Mermaid, and it gives you a diagram. I'm like, okay, that's cool, right? Well, I have, I have all my architecture as data. What could I do with that? And then what if I had all of the architecture patterns that I want to standardize on, explicitly modeled as data, and then said, hey, tell me where this pattern exists in the architecture. I'm not saying that can be done right now, but I'm saying the problem seems shaped in a way that we could use some of these AI solutions to start to get back to one of the things that's really important to me, which is situational awareness and decision making, which is, again, the human side of resilience. Before you respond, you want to make sure you actually know where you are and what's happening and what's true. And so often we don't have that information. We find out, hey, we need to respond to X, with X being, it could be a performance problem, it could be a security issue, it could be a new line of business that they want to roll out by surprise, right? Nobody knew. We say, okay, what's going to be impacted by this? Like the number of times I've heard that exact question, what will be impacted by this thing that just dropped in our lap? Nobody knows. Mm-hmm. Nobody has a clue. And it's because the problem of answering that question is usually too big to be contained by one mind anyway. Which is why it's like, oh, well, what's good at modeling big things that won't fit in my brain? Oh, computers, right? So again, you get back to this idea of, well, hey, if I want to know what's impacted, well, if I model all that stuff and I model all those connections, then I say, okay, hey, if this thing has to change, what all's connected to that thing that may be impacted based on what I know in the model? That's a very algorithmic question at that point that, I can just say, computer, go give me this situational awareness that I can look at and then say, oh, okay, well, this list of things I don't care about so much, but this thing right here, this is really critical. So let's figure out exactly where the impact. And so I start to be better at making decisions about how to respond. That's resiliency.
Yeah.
Just as much as your system auto scaling on your behalf. Really, all that auto scaling is a result of that same deliberative process that you had to make this other decision. It just so happens that your platform's giving you a tool to, hey, decisions of this type, we can just trigger those and make those automatically happen. And so, when you can get to it's that level of decision, then yeah, automation becomes clearly the next step. But if we can't automate something, it's almost like we throw up our hand and say, well, we can't be rigorous about it. Yeah, we can. And I'm not saying that we need to be like safety critical system rigorous about everything that we do, but just like everything else in this world, pretty much that I'm aware of, it's a spectrum, and you choose, where do you want to be on that? And you're always choosing, right? The decision not to choose where you're going to be on that spectrum means that you're going to default to wherever your collective organizational behavior causes you to end up.
Yeah. And okay. So there's like just some of my notes here to touch on.
Okay.
One, I really liked your point about decentralization requiring more rigor. Mm-hmm. And then I kind of wrote a little thing down for myself of like rigor as resiliency ? You know, that's oversimplifying, but it's just a like, hey, is this a prompt that we need to think about? And I have questions about what you see. You know, you said you've been seeing this as like an emerging, almost like the sounds a little bit like the microservices hangover, right? Like, for lack of a better description, you know, and is like, and how people are treating that hangover is with rigor. And then in terms of, you know, like being able to model a situation, kind of coming back to that, to your point, right? How do we have situational awareness to support decision making as that part? And I like how you you connected that with things like auto scaling, or really any kind of automation, to your point, where it's like, hey, those are the events that we've already forecasted are going to happen. And we've already decided that we know we want them to be handled in a certain way. And there's like, that is 1 degree in like a, you know, 3-dimensional sphere of possibilities.
Right.
That as many of those degrees that you can model out and say, hey, we know in this situation, we want these things to happen. If you already have that, if you have enough situational awareness and you've made that decisions, then absolutely automate it. But for everything else, and there's a lot of surface area for everything else, then your goal is to get as much situational awareness in the time you need it to be able to make a strong decision. Because if you know, without making a decision, the decision is still being made for you. You are still deciding something.
Yeah.
And so those were just some of the things. Like, I think I probably have time for like 1 or 2 more questions here. And so
Okay.
I'm thinking about, like, do we want to lean into, you know, rigor for resiliency, and like practices and things to think about how do you bring rigor back? Or do we want to kind of look into how almost like that practice of how much time, or how to think about time that should be spent on, hey, are you thinking about how much surface area can you cover off with, these are things we expect to happen. Scaling is just one, right? We know there are other things that we know will happen.
Yeah.
Why not model those out and make your decisions ahead of time in a similar way, and just have that much more, you know, pinholes in the night sky that are covered? Or is that kind of like, hey, you're talking about the night sky and there's no point?
So I think the second one's a little more open-ended. I think we can actually do as much justice as we'd be able to do to the rigor question relatively quickly. You know, the next level down from what I'm going to say would be another conversation in and of itself, a series of conversations, honestly. But when I say rigor, I know that that's going to be very triggery for a lot of people, because we have many times applied rigor in a way that was either not communicated well. Like, why we're doing what we're doing was not communicated well. And so people didn't always understand why they were being forced to do the things that they were being forced to do, and why they couldn't do it this other way. And I found that when we actually communicate well in those situations, and we trust people to understand the context surrounding why these guardrails are in place, most people are going to behave reasonably, and not, you know, that they say, oh, I get it, I know why we're doing this now. But for some reason, we just aren't good at connecting sometimes the mechanical things that we do in the name of rigor with why does this matter?
Mm-hmm.
And when we do that reasonably well, people tend to be a little bit more accepting of it. I know I have. And then there's also, kind of the added element to that of there always needs to be an escape hatch. So that when you do come across the thing that doesn't fit, and everybody agrees this is the thing that doesn't fit, that you have a mechanism to allow you to make a new decision about that thing. And so many times we don't put that in place. And, it either ends up being, we're massively subscribed as far as the knowledge that we have to depend on when we get to that point, or we never actually do anything because we're still trying to figure out all the things that might happen and add all that to our meta model of our thinking. So, the one, knowledge base to rule them all, the pattern to rule all patterns, right? These are some different, dysfunctions that if we're not very careful, any of us can end up at, because we've repetitively done each of these different anti-patterns. That's why they're called anti-patterns, because they show up a lot of times. It's there's a certain sense in which we just have to recognize that, holding all other things equal, humans will behave in certain ways, given certain constraints. And it's like, okay, cool. We know that. So what can we do about it? To maybe to be thoughtful about that. So that's when, so rigor is just, okay, hey, how do we create a machine that, the 80 to 90% of the time that it just needs to behave like a machine and do the things that we said we're going to do, that it does that extremely well. But then when we get into those exceptional scenarios, that it gives us the flexibility that we need to come back out and say, oh, well, do we need to change direction? Or do we need to handle this particular situation differently than the rest? Is it truly novel? Or is it something that actually does impact everything else? And we actually need to start changing that machine a little bit to make it a little bit more capable or a little bit more resilient. In the Bone video, when he talked about resiliency engineering, it was a little too close to home because I've had some, unelective orthopedic surgery in my life, and I am a little bit bionic. I have some plates and bolts in certain spots to hold things together. That'll be there, as far as I know, for a long time. They've already been there for half my life. And but what so much of the stuff that we do in that realm is like, how do you take the resiliency that already exists in the system and, either nudge it in the right direction? So like when a bone breaks, if you don't align it, it's going to heal itself. Yeah. But it's going to heal itself in a way that's suboptimal, right? Align it, that's resilience engineering, right? Or, we put in, some of these plates and grafts and things to make things stronger, to heal in certain ways, so that, hey, we know that if we don't do this, it's going to be more likely to fracture later on. And so we're engineering a solution, or we're engineering something just to make sure that everything stays still long enough to set, right? Get enough of that bone replaced that, and so all of those things are kind of meta to the machine. He said in the video, he calls them above the line and below the line, which was a completely differently defined term in our past lives together. So, but yeah, it was this notion that the stuff below the line is the stuff that's already built into the system. It's already built into the bone. Now the auto scaler is part of your platform, right? That stuff is there, right? Yeah. Resilience engineering is the stuff that the people are doing above that to, make this bigger socio-technical system, is the big fancy word I like to use to describe it. But it's the system is all of it. right? Because anytime something goes wrong, all of the parts eventually seem to end up you rarely do you ever have a situation where there's something that rises to the level of something you would call an incident that doesn't have humans involved. So let's just quit pretending that they're not a part of the system. They are. The system can't respond without them. So the system does not work without them in all circumstances. So therefore, they're a part of the system. And so once we acknowledge that, then we can start to apply rigor to, okay, well, what are the ways that the humans interact with the system in these situations? It starts with things like run books, for example. Like, we still write those, right? We still need those things because some situations, that's the best we can do. And so rather than saying, oh, we don't do run books anymore, so those systems are just not covered, saying, no, we do run books where we do run books. I tell people, it's like, hey, where a make file will work, I use a make file, right? You apply, you learn over time that the old tools still work.
Mm-hmm.
Just because the new tools exist doesn't mean that the old tools always stopped working. A lot of those old tools, if I turned my camera this direction, you would see my hobby setup over there, which is a couple of Commodore 64s and a soldering station. All that stuff still works. And you can actually learn a lot of interesting things about architecture from how people made systems. Like we take a little React framework and we build a little UI, and it's so freaking easy to do. Like, so okay, recreate what you just built in React on a Commodore 64 without killing yourself. Like, it's wild because you're writing everything in assembly language. Why? Because the computer can only handle assembly language. You have to write tiny programs to fit the thing you want to do. So should we go back to doing that? No. But we've built all these layers up from there. We've built more and more rigor about, like, if you write a piece of software for the Commodore 64, you have full control over the computer. Like, you can literally make any chip in the computer do anything you want. I can't do that when I write a Lambda and upload it to the cloud. Like, there are layers of rigor between me and the assembly language and the machine code that eventually does execute. And so I'm just saying, hey, like, let's acknowledge that there are more layers here, and we can be rigorous without being draconian, without, process is not the problem. It's creating process that knows how to change.
Mm-hmm. Okay.
Rigor is not the problem. It's how do you make it to where you can always be dynamic in how you are applying rigor. And then also the way you apply rigor in different scenarios isn't going to be the same all the way. Like, take S3, for example. There's a paper that you can go see. Here's how Amazon uses formal systems design to run S3, because basically, like, we know what that system needs to do, and we know exactly how it needs to do it, down to the level of every little thing that goes wrong. Here's what needs to happen. When you actually know that, there are actually other techniques that you don't go write user stories for that and do Agile. Agile is about what you do when you don't know what you're building. And here's how you learn what you're building while you're building it. When you go build, hey, I need to build a highly redundant 8-9 storage system that you can put things into buckets and you can take things out of buckets. That's basically what it does, right? And but it does it with a extreme amount of rigor so that you can achieve that level of nines. And so, yeah, you're probably not building that, but you start to back down this, you find, oh, here's the level of rigor that's right for this problem, and then you apply it. Right now, Now, what does it look like for you? I have no idea, because that's where the contextual thinking comes into play. You have to figure out, hey, what rigor is going to work here? And I would suggest, hey, think about the least amount of rigor that you can add and try it.
Mm-hmm.
And then if that works, like, okay, well, maybe we thoughtfully add a little bit more. Or if that completely blows up in your face, back up and say, okay, what did we not understand about our system? Because we thought that was going to work, but it didn't. So what do we, it's not enough said that doesn't work. We need to try something else. Why? And what's the explanation for that? That's part of the rigor as well. Just trying, thinking is such an important part of what we do. And learning how to think collectively is even harder because, of course, there's all the different organizational dynamics and anti-patterns of thinking that you can go read about. Groupthink is just one piece of that puzzle. But yeah, our response has not always been that great as to, okay, we know that it's hard to think as a group. Okay, so what are we going to do about it? I don't know. This is just hard. We complain about it a lot. As I've never met someone who does not acknowledge that this is a huge problem, but I'm like, okay, industry, we all recognize this is a problem. Let's think about how to solve it. Maybe let's take a pause on trying to build a new technology to do the same thing every 5 minutes and start to look at some of these, these socio-technical systems ideas that the people who are doing this really well, they're thinking about this stuff.
Mm-hmm.
They might not even tell you that they're thinking about it because it's just kind of in their DNA, right? It's just how they operate. But if you kind of observe how they behave, you say, yeah, they're thinking about the people and the software working together, and acknowledging that one doesn't really change without impacting the other in some way. And then all those different connected pieces of software are doing the same thing. And so, like, back to your second question, which I said I was going to do rigor faster, but I lied. Like the things that we know, hey, these things we understand well. That works to a point. But then you have to ask the question, okay, when I scale this, what does that do to that? Times the number of possible situations that can occur, right? So while you can say, hey, I know that at this local level, that if this number goes past this line, if I add 3 instances of this service, that will go back down to an acceptable level. That doesn't mean do that until you actually know, okay, well, if I'm automatically doing that in response to this, what impact is that going to have? I don't know a lot of teams that ask that question. And part of the reason is, again, coming back to situational awareness, we don't have the information available. Could we? Almost definitely. But we haven't invested in modeling the system that we're actually, in charge of operating and maintaining and evolving over time. The only model we have of it is the system itself. And there's going to be probably a group of people who hear what I'm saying and say, well, you don't need a model because you got the system. And I'm like, well, it depends, right? Again, in an ideal world that doesn't exist, where you have, built your software in such a way to make its model completely observable. And then you can actually go to that system and say, okay, well, what if I do this? Does that make things better or worse? The only way we have to do that right now is to do it for real.
Right.
Right? So the thing that I'm really starting to get interested in is, okay, well, there are certain systems that, by golly, if something goes wrong with this system, it's going to be way beyond my pay grade to explain what happened. So we're not going to apply chaos to this thing, and that's a very well understood decision when you get outside of the realm of consumer internet services, right? Where, okay, you can't get your movie, big deal, you're fine. Over here, it's like, oh, this is going to be a world apocalyptic event if this service doesn't work. Probably, but can we simulate? Can we take that model to the next level and say, okay, I have a model of the system, and I model its behavior, and I can make certain simplifying assumptions that say, okay, based on what I've seen this system do, I know that if you have stuff coming in the door at this rate, it's going to go out the door at this rate. And so model that, and then simulate stuff coming in the door at that rate and going out the door at that rate, and then start moving things around and saying, okay, what happens if I do this? What happens? What happens if I change this? What happens if I disconnect this? In an ideal world, you could do that to a real copy of the running software, but I don't know anybody who lives in a world where, and I'm not saying they don't exist, I'm saying I don't know anybody that lives in a world where they have an exact copy of their production software that they can go to and manipulate the way I'm describing in a cheap way, like a cost-effective way. Say, hey, I can do this in such a way that I can get an answer quick enough that it's cheaper than just doing the work. I'm convinced that you can. I haven't figured out how yet. This is an area of research for me right now, but I've been in enough scenarios over the last few months of, gosh, I wish I just had a way to simulate these two alternatives and just do an experiment and compare very quickly, what are the characteristics along this dimension? How does this perform versus this? Let's say I use this load balancing solution versus this other one, and I know what the characteristics of the two are algorithmically. So I can simulate that algorithm and then just, hey, run it, see what happens. Is it going to be an exact replication of what happens? No. Is it maybe going to be close enough to help me make a better decision? That's my hope. I mean, ultimately for me, everything's about getting to making better decisions. Everything in this space that we've been talking about for the last hour is about how do we get the right information at the right time to make the right, and by right, I mean the most optimal decision that we can make in that particular moment. How do we make sure that those things always come together? And that's where I'm kind of convinced that, well, hey, we probably need to model that with the same rigor that we model other things. Yeah. And I'm not the only one talking about this. Like, there's a lot of the ideas that I'm talking are coming from what I think Charity that you're going to have. I've heard her say a lot of similar things about how you think about this problem. And how you ask different questions and get different views that are contextually sensitive to what you're doing so that you can make good decisions. To me, this is where we're going to go. I hope. Yeah. So yeah, that's where I'll leave it.
Okay. Well, I mean, thank you, Matt. I've taken pages of notes, and I think there's some like a lot of good food for thought for folks here. My last question, like, one word answer in the spirit of the season, is it pumpkin spice latte or apple cider? Like, what's the Halloween Eve drink?
I will say that I've had some pumpkin spice ales that were actually quite good. Okay. And I tend to, I tend to like the fruity beers. So I'm a coffee snob, so I usually drink coffee black. um, Occasionally, I'll put some cream in just to, to take a little tinge of the acid off if I've overdone it on like the pour over or something, or we leave the cold brew in the refrigerator for too long, because we make cold brew every day. So yeah, but so no pumpkin spice allowed in that space. Now my daughter completely disagrees, but that's okay. She can have a different opinion on this, but yeah, I do like the pumpkins, and I like the ciders too. I was just in an event where there was like literally a couple hundred different varieties of beer that you could just have as much as you wanted, because it was part of your ticket. Of course, there's a limit to what you can do at my age and with my stomach, but yeah, I had some good stuff, and there were some ciders and some pumpkin spice among them, so I would recommend both. I'm not gonna make a choice.
Okay. So
not a one-word answer. You're not gonna get a one-word answer out of me.
Proven fact. All right. Thank you so much, Matt. Just to remind folks, we'll be back with Ashley Ward from Orca Security, and then we'll have Charity Majors and James Governor on. And then shortly after that, we'll have Jamie Vernon talking about a culture of automation. All right. Thanks, everyone. Thank you, Matt, and have an uneventful rest of your day.
All right.